Hello, I'm your TA. In this video, I'm going to demonstrate you how to solve 14.1 in Howell 8th edition. Take a few seconds to read the scenario first. Let's solve A. So write the statistical model for this data. If we assume that there's no interaction, we can write the statistical model as Xij is mu plus pi I plus tau j plus eij. If we assume that there's interaction, we can write as Xij is mu plus pi I plus tau j plus pi tau ij plus eij. Here, Xij is the scores on GRE and mu is grand mean. So pi I is constant associated with the subject I, representing how much that subject differs from the average subject. Tau j here is constant associated with the j test, representing how much treatment, here is test, mean differs from the average treatment, here is test. And eij is the experimental error associated with subject I and level j. Pi tau ij is the interaction of subject I with treatment j. You can find the related slide in Unit 8, repeated ANOVA, Part 1, slide number 28. Let's go over letter B. Because each subject took the standardized admission exam every Saturday morning for 3 weeks, we could know that these GRE scores are measured repeatedly. So we can run repeated ANOVA. I'm going to show you how to calculate the repeated ANOVA with formulas. I will not do hand calculation because the numbers are too high to do hand calculation and it's too complicated. But I'm going to show you how to do with Excel. I'm going to also show you how to do SPSS. Before calculating, we need marginal means. So we are calculating column means and row means. Marginal mean. These are marginal means and this is grand mean. Because the row represents the subject, which is I, and the column represents test, 550 can be written as X11 and 440 can be written as X21 because the row number is written as first and the column number is written to the right. So second one is because this is the first row, second column, X12. Because 580 is written as X13 because the first row, third column number. So X1 here, 1, 1, 1 does not change. However, number 1, 2, 3, the number of column is changed. We can rewrite this one as X1 dot bar. Second row, 440 can be written as 22. This is X23. 2 does not change. However, the number of column, which is 1, 2, 3, is changed. We can rewrite this one as X2 dot bar. Let's see 552.50, which is the first test mean. We can see the number of column is same. However, we could know that the number of row is different. We can rewrite as X dot 1 bar. To generalize, we can rewrite row means as xi dot bar, and I is number 1 through number 8 because we have 8 subjects. And we can rewrite column means as x dot t bar, where t is 1, 2, 3 because we have first test, second test, and third test. And we can write the grand mean as x dot dot bar, as same as we were done in the previous videos. We know that I means number of subject, T is the number of test here. Sum of square between can be written as T, this is the number of test, sigma I is 1 to the number of subject. I will write as a large I, x I dot bar minus x dot bar squared. Because we have three tests, 3 times, because xi dot bar is the row means if I plug in I as 1, x1 dot bar, which is 566.67, so 56667 minus grand mean squared plus the second row mean 450 minus 563.33 squared up to the last row mean squared. This is 189,666.67. And degree of freedom for between is, because between means subject, the number of subject, I will erase this one, number of subject minus 1. Here is a minus 1 is 7. And mean square is sum of square between subject and degree of freedom of subject. I made this line as the gray color because if we add these two numbers, we can find the within number, and we can find two numbers if we sum them up. This is the degree of freedom of within. I'm gonna show you how to calculate the sum of square test. I times, this is the number of subject, here 8, sigma T is 1 to T dot T bar minus grand mean squared. We have A subject, so A times the first column mean is 552.50 minus grand mean squared plus second column mean is 563.75 minus 563.33 squared plus the third column mean is 573. The value is 1808.33. The number of degrees of freedom is the number of test minus 1, which is 3 minus 1 is 2. And mean square is sum of square test by divide degree of freedom of test. 904.16. And sum of square error is too complicated. I am going to calculate the sum of square total first. Sum of square total is, we need to calculate the difference between the all test scores and grand mean, square them, add up all these numbers. So I'm gonna show you how to do this one with Excel. I'm gonna show you how to calculate the marginal means. You put the equal sign and average, and you just hit the B2 to D2, and then close the parenthesis and hit the enter, and you can drag and drop. And if you want to calculate the column mean, you can also write equal average, open the parenthesis and drag up to B9 and close the parenthesis, and you can drag down. And then you also put the equal sign and average and drag all. I'm gonna change this one as number. I calculate the marginal mean, which is highlighted as yellow, and these are my row means, and these are my column means. We need to calculate the difference between each test score and grand mean. So here, test 1, 2, 3 equals, because we need parentheses first, parentheses, hit this number, minus grand mean, close the parentheses, and shift 6 and 2. This is the squared. Enter. Because our grand mean is fixed as 563.33, we can $sign in front of E and number 10. We can fix my grand mean. If I drag to the test 3, it automatically generated. So this is 580 minus grand mean. Because we fixed the E10, that is why we can safely drag and drop. And then let's drag down up to subject 8. This is all the difference between each test score and grand mean and squared. We need to add up these numbers. So the sum is, put the equal sign, and sum, open the parentheses, and drag and drop all the things. So this is my sum of square total. So my sum of square total is 194,933.33, because the sum of square total is sum of square between plus sum of square test plus sum of square error. We want to calculate sum of square error, we need to move this one to the left side. So sum of square error is sum of square total minus sum of square between minus the sum of square test. The value is, if I add these two numbers, that is my sum of within. So which is, degree of freedom of error is number of subject minus 1 and number of test minus 1. So A minus 1 is 7 and 3 minus 1 is 2, which is 14. So if I sum them up, 2 and 14, which is 16. And if I add this cell, and this cell, that is my degree of freedom of total. 7 plus 2 plus 14 is 23. Always degree of freedom of total is the number of all scores, GRE scores here, minus 1. So we have 24, GRE scores minus 1 is 23. And mean square for error is sum of square error divided by degree of freedom of error, which is 247.024. By adding these two cells, you can also calculate mean square within. Add up, that is, and my F value for the within is mean square test divided by mean square error, 3.66. My critical value with alpha is 0.05, and degree of freedom is, my degree of freedom of numerator is 2. My degree of freedom for the denominator is 14 in the Howell textbook, which is 3.74. In the F graph, and my observed value is 3.66, which is not in rejection area. I failed to reject the null hypothesis, meaning that there is no significant practice effect. So I'm gonna show you how to do in SPSS. Go to Analyze, General Linear Model, Repeated Measures. We need to set the name. So I will set my factor name as test, and there are 3 levels. Define, We need to put first, second, and third test to the within subject variables and subject to the between subject. Okay, and we have the result. I'm gonna let you know a little bit about the sphericity. So for my null hypothesis for my sphericity is sphericity holds versus my alternative hypothesis is sphericity does not hold. When we have the significance p-value here, when we check the p-value here, p-value is less than 0.05, which is my alpha, we reject the null hypothesis, which means that sphericity does not hold. And p-value is greater than 0.05, which is my alpha, we fail to reject the null hypothesis, which means that sphericity holds, which means that there's no evidence the variance or covariance are heterogeneous. So once we know the sphericity is a hold, we can check that this line, and this line. These three lines are the adjustment when sphericity does not hold. When we have the sphericity is a hold, we only see these lines. We can compare my within subject effect. So sum of square when sphericity does not hold, I recommend seeing the greenhouse line. However, we are assuming that sphericity is a hold, so we can find these numbers are matches to our result. We can write here at 1808.333. This is error in within. Between subject effect is here. We don't need to see the first line. We only see this line as between. So we can copy 189,666.667, which is matches to our result. So we are done letter ABC in exercise 14.1. Thank you for watching this video. If you have any questions, please reach out to me. Bye.